Okay, so we'll start with the dry test for basic radical, and the very first test in dry test is heating in a dry test tube. So we have to take a small quantity of salt in the clean and dry test tube and will heat it. Okay, so I am taking little amount of salt in a dry test tube and we have to heat it to check what are the observations we are getting. We'll heat it. You just have to heat the salt as it is. We are adding nothing into that test tube. Test tube should be dry and clean. So while heating you have to observe what are the changes taking place. I can hear the cracking noise which is called decrepitation, and if you observe here there are water vapors condensed and the residue which is formed is of white color. One more observation you can see is the formation of white sublimate. On the sides of the test tube white solid is sublimated here. So you can see the white sublimate. So these are the observations we have got by the first heating test. Okay. So make a cavity in a charcoal. Start. So make the cavity inside the charcoal, and now we have to fill the salt mixed with sodium carbonate in 1:2 proportion. So first of all make a paste of salt and sodium carbonate with water and fill that paste in this cavity. So we have to make paste of substance. This is the salt we are taking for the analysis, and we are mixing it with the sodium carbonate Na2CO3 in 1:2 proportion. I am taking salt on the watch glass, and then I have to add sodium carbonate. Now we have to make the paste of this mixture. We are taking salt and sodium carbonate in 1:2 proportion. Add 1 or 2 drops of water. Now we have to fill this paste of salt with sodium carbonate into that cavity that we have made in the charcoal. And now we have to heat this mixture with blowpipe on a reducing flame. So first of all you have to adjust the flame. This is what oxidizing flame is. We have to adjust it to reducing flame, and we are going to heat this mixture or this paste on the reducing flame. So this is what called reducing flame, and by using the blowpipe we have to heat it. So here we can see that there is no red scale formed or there is no incrustation, but we have got white infusible residue. And according to the dry test, if we get white infusible residue, then there will be Zn plus 2, Al plus 3, magnesium plus 2, barium plus 2 may be present. So we have got white infusible residue in this particular charcoal cavity test. Okay. If we get white infusible residue in charcoal cavity test, then we have to add 1 or 2 drops of cobalt nitrate on that residue, and we have to heat it again. So I am adding. So it is 1 or 2 drops of cobalt nitrate on the white infusible residue. Now we have to heat this residue on oxidizing flame. So first of all, adjust this flame to the oxidizing. And then again we have to heat that. Here you can see that residue turns grey, and if this residue turns grey, here you can see the residue has changed its color to grey, and therefore we can say that barium plus 2, calcium plus 2 may be present. So basically on this dry test will give you the choices or predictions of which cations are present in that particular salt. So here we have got the grey colored residue in cobalt nitrate test. So now we will take other test. Okay. Next test we are going to perform is flame test, and for that we have to take a platinum wire cleaned with concentrated HCl. So I am taking this platinum loop, and now you have to make paste of your salt with concentrated hydrochloric acid. So I am taking salt on this watch glass. And add concentrated HCl. Just have to moisten that. This kind of paste. Now put this paste on your platinum wire and heat it on oxidizing flame. So I have adjusted the flame. And we just have to observe the color of the flame. So here, just check what is the color. If you can see this color, which is greenish, or you can call apple green, avoid the orange color which is seen, but in between you can see the greenish shade of the salt. So we have got this apple green color. Number. This greenish color flame, which is due to the presence of barium plus 2. Okay, here we have got in flame test apple green flame, and therefore barium plus 2 may be present. Next step in the analysis is dry test for acidic radicals or dry test for anions. So we are going to perform the first two tests. First one will be action of dilute HCl, and for that you have to take a small quantity of salt in a clean and dry test tube and add dilute HCl and check what are the observations. So I am taking some salt in the test tube and I have to add dilute HCl. So while adding dilute HCl, you can see that no effervescence are formed. So here the first observation we have not got, which is effervescence. Then we didn't get any burning sulfur smell or reddish brown gas. So we have got no any observation in this first test, which is action of dilute HCl. Okay. So the second test for dry test will be action of concentrated H2SO4. So I am taking salt in the test tube and I am going to add concentrated sulfuric acid. So here I have added concentrated sulfuric acid in this rod. So we have to check the glass rod dipped in ammonium hydroxide and the fumes which are coming out of the test tube. We have to check whether these fumes turns dense or remain as it is. So we have to put one glass rod in this solution which is of NH4OH. So instead of using glass rod, I am using the stopper of that bottle and I have to dip that stopper into the solution of ammonium hydroxide. So in this way we have to dip the stopper into the solution and I have to put this dropper at the mouth of this test tube. If you can see, the fumes are coming out of the test tube and I have to check what is the change in these fumes. So I am putting this near the mouth of the test tube and you can see that these fumes strike the stopper and they turn dense. So this is what called dense white fumes with the glass rod dipped in NH4OH. And because the fumes turns dense, we can say that colorless gas giving dense white fumes with NH4OH. So this is our first observation and therefore chloride may be present. So this is the dry test. So we cannot say chloride present, it is may be present and we can check the presence of chloride by using wet test. But for now we have detected the dry test for chloride. So I am going to analyze the group present in the given mixture. So first of all we have to find out whether zero group is present or not. So for that the first test is analysis of zero group and for that we are taking OS and NaOH solution and heat it to get the smell of ammonia. If you get the smell of ammonia, you can say that group 0 is present and for that we are preparing first OS. So take your compound in a test tube and add sufficient water to dissolve it. We will start to analyze the group present in the given compound and for that first of all we will find out whether zero group is present or not. So we will do the analysis of zero group. For that we are taking OS and NaOH. Now we have to heat this solution and hold the moist turmeric paper near the mouth of the test tube to check whether the ammonia gas is evolved. So first of all heat the solution So while heating this solution, you have to check whether ammonia gas is evolved by smelling it. If you can smell the ammonia gas, put the moist turmeric paper near the mouth of the test tube. If this turmeric paper turns red or brown, you can say that the NH4 plus or group 0 is present. Here there is no effect on the turmeric paper, so we can say that 0 group is absent and I cannot smell ammonia gas. So in this particular compound 0 group is absent. So now we will move on towards the analysis of first to 6 group. Okay. So we have got 0 group absent in this compound. So I am starting with the detection of groups from first to 6. And for first group detection I am taking this OS. Take your OS in the test tube and add dilute HCl to it. Whether see white PPT is formed or not. So I am adding dilute HCl to this OS. You can see there is no PPT form. So we can say that for this first test, which is OS plus dilute HCl, there is no white PPT. So we can say that first group is absent. Now we will move on towards the second test. It is OS plus dilute HCl plus H2S gas or H2S water. For this test, we have already taken OS and HCl in this test tube. So I am adding just H2S water so that we can check whether black precipitate is formed. So you can see there is no PPT formed and therefore group 2 is also absent. So now we will see the third test for the group detection and it is OS plus NH4Cl and we are adding NH4OH to this test tube, but make sure that your NH4Cl dissolves completely in the OS and then add NH4OH. So I am adding NH4OH to this solution. Add NH4OH till the solution becomes alkaline. So you can see there is whitish turbidity formed, but it is not precipitate. So you cannot say precipitate is formed. So there is no precipitate and therefore third group is also absent. Now you can see the next test for group 4. It is OS plus NH4Cl plus NH4OH and you have to add H2S water to that solution. And we have already taken 3 of the reactants. So I am adding H2S water. So here also we are not getting any precipitate black or pink or white. So we can say group 4 is also absent in this compound. Now we will move on towards the next test, which is OS plus NH4Cl plus NH4OH till alkaline and saturated solution of NH4 twice CO3, that is ammonium carbonate. So we will take some amount of OS, then again we have to add ammonium chloride, which is NH4Cl. Add NH4OH till alkaline. And the saturated solution of ammonium carbonate, that is NH4 twice CO3. Here you can see the precipitate is formed, and if you stabilize this test tube, the precipitate will settle down, and if white precipitate is formed, we have to say that group 5 is present. So in this particular salt or in this particular compound, we have got group 5 present, so no further analysis is necessary. We have to stop here, and we got group 5 present. So next step of this analysis will be the analysis of group 5, as we got group 5 present. So we will stop group detection here. So we have detected the presence of group 5 in the given compound, and now we are moving towards the analysis of group 5. So the next step in the analysis is group 5 analysis, and for that the first test will be OS and K2CrO4 potassium chromate. So I am taking OS. This is potassium chromate. Here we get yellow precipitate. So you can say that barium plus 2 is present. So while analyzing group 5, we got the first radical, which is basic radical and cation, Ba plus 2. Now the next step in the analysis is to confirm the radical which is present. So we have got barium plus 2 present. So I am doing the confirmatory test for barium. So they have given two different tests for confirmatory. First one is same as that of the analysis, which is OS plus K2CrO4. So I am doing the second one, which is OS and dilute H2SO4. If we get white precipitate, barium plus 2 will be confirmed. So take this for confirmatory test. We are taking OS, and we have to add dilute H2SO4. If we get white precipitate, barium plus 2 will be confirmed. So I am adding H2SO4, dilute H2SO4 to the OS. And you can see that white precipitate is formed. So barium plus 2 is confirmed here, and we got our first radical, which is basic radical. It is barium plus 2. So here the analysis of cation or basic radical is completed. Now we will move on towards the acidic radical. So we have detected the basic radical in the given compound. Now we are moving towards the acidic radical, and for that we are doing this wet test for acidic radical. So first of all, we will do this first test, which is for carbonate, sulfite, chloride, bromide and iodide. So these 5 radicals are to be detected by the first test, which is of OS and AgNO3. So we will take OS and we will add silver nitrate into that OS. So if we get white precipitate, we will move on towards the next test. So first we will see if we get white precipitate or not. If we don't get any white precipitate, or if no PPT, all these 5 radicals will be absent in that compound, and we will move on towards the second test, which is for sulfate and phosphate. So first of all, we will check whether OS and AgNO3 gives us white PPT or not. So first I am taking OS, and we have to add silver nitrate or AgNO3. You can see that the precipitate is formed at the top. As we add silver nitrate, white precipitate is getting formed. Now, as I have discussed earlier, that if the white precipitate is formed, acidic radical out of these 5 must be present. So as we have got this white precipitate, there is carbonate, sulfite, chloride, bromide or iodide. Now we have to find out of these 5 radicals which one is present in the given compound. So for that we have to add dilute HNO3 in this precipitate, and we have to check whether this precipitate is soluble or not. So I am adding dilute nitric acid. So as you can see that precipitate is not dissolved in nitric acid. So they have given that if the precipitate is soluble in nitric acid, there must be carbonate or sulfide. And if the precipitate is insoluble, there will be chloride, bromide or iodide. And as our precipitate is insoluble, there is chloride, bromide, iodide present in the given salt or given compound. So we have got white precipitate which is insoluble in dilute HNO3, and therefore chloride, bromide or iodide are present. Now we just have to check. We have got chloride, bromide and iodide in the given salt, but we have to find out whether chloride, bromide or iodide is present, and for that we are performing this test which is called distinction between halides. So we have got chloride, bromide or iodide, and now we are going to find out which of these halides is present in the given salt, and for this we are performing this distinction test, and it is OS plus chloroform plus chlorine water. We are adding chlorine water in excess. So I am taking first OS, then we have to add chloroform, this is chlorine water. You can see there are two separate layers formed, and the bottom layer is of chloroform, and they have given that if there is colorless chloroform layer formed, then halogen which is present is chloride, and we have got here chloride present. So we have detected our anion, and now the next step will be the confirmatory. Okay. So we have detected the presence of chloride anion in the given salt. So the next step will be the confirmatory test for chloride. So there are two tests given for CT. We are doing the second one, which is OS plus lead acetate. If we get white precipitate, chlorine will be confirmed in the given salt. So first of all, take some OS in your test tube and add lead acetate. If you get white precipitate, chlorine will be confirmed. So if you can see, there is a formation of strong white PPT. So we can say that chloride is confirmed here. In this way we have detected the presence of cation which is barium +2 and anion which is Cl-. Okay.